heating effect here, that for electricity, is also known as Joule's effect. First of all, you must know the obstruction, hindrance or the opposition created by the material in the flow of current is known as resistance, and because of that resistance, whenever the current flows through it, heat is produced. But this effect, that is called Joule's effect, is not reversible. It simply means that by the current you could produce heat in the wire, but by heating the wire you are not going to get the current. The amount of work done with the help of current is stored in the form of energy, and that is consumed as or dissipated as heat. Q equal to V into Q. This could be written in various ways, that is I²RT or even V²T upon R. You see, for measuring the electric energy or the heat energy produced here, when you say heat energy produced, is equally good as electric energy consumed. Both are the same. So, this could be measured in the unit kWh, that is known as kilowatt hour. The trade field has the name unit, short form of Board of Trade unit. The number of units are obtained with the help of the relation volt into ampere into hours divided by 1000. 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. This is in general known as unit only. The number of units, you know, sometimes in place of volt into ampere, it is written as watt. It is all the same. Watt itself stands for volt into ampere. 1 volt ampere itself means watt. Now, power, you know, is rate of work being done. Here, the amount of heat produced per unit time, or you might say the electrical energy consumed by the appliance per unit time, that will be known as power. For power, you have the unit watt, and watt into second, that is joule. By doing all this, we ultimately conclude kilowatt hour. For power, you have 3 types of relations depending on these 3, that is VI, I²R or even V² upon R. You see, while dealing with electricity, you must be aware with one very common convention. That is not convention, that is not tradition, it is a demand of the science, demand of the mechanism of electricity, that all the domestic appliances are always connected in parallel combination. And you know, in parallel combination, what is common throughout, that is voltage. So, it is always advisable for bulb makers, that means factory, those who are creating the brand. For them, it is essential that they should always consider the bulbs in terms of voltage. While deciding the power, they have to think in terms of the relation that involves voltage, like this one. So, they must be knowing, they must have to conclude and keep in mind that for increasing the power of the bulb, the resistance has to be decreased. So, whenever we decide the power, we have to control the resistance of the bulb used. These are the 3 relations. When some bulb is specified, suppose this colored bulb, that is very attractive and having a good message for you, that this is bulb of 60 watt, it is given over there. You go to the shopkeeper and you simply put the demand, I need a bulb of 60 watt. Now, that shopkeeper is not going to ask you what's the demand of voltage by you. He won't ask, it is understood. It is a common convention that all the domestic appliances are meant for 220 volt. So, you are demanding 60 watt, it will be understood that the bulb is at 20 volt, and it also carries the meaning that when the bulb will operate at 220 volt, the power consumed by it will be 60 watt. Now, it is inherent, it is understood, it could automatically be derived that what would be the current when the bulb is operating at full swing. The current could be calculated by this relation, the 60 watt and the volt is 220. You could find the current that will flow corresponding to full consumption of this bulb.